All right, Chem AP Aces, are you ready? We've got another Chapter 4 lab for you. This one's a Redox lab, okay? And it's going to involve titration, which we'll show you in a minute, but first you need a little bit of background information. So, what we're doing is we're going to react hydrogen peroxide and potassium permanganate. All right, so we're going to have a permanganate solution with a known concentration, 0.150. That's going to be in the burette. It's got a really nice deep purple color. And we're going to use that to titrate a hydrogen peroxide solution. And later on, we'll tell you what question it is you're trying to determine. Okay? And you need to know this maybe. In acidic solution, permanganate ions change to Mn+2 ions, and hydrogen peroxide molecules change to oxygen molecules. You're going to need that information. You're going to have to try to create a net ionic equation for yourself so you can do the stoichiometry in the particular drug.
Will we have to balance the net ionic equation too?
I will think you need a balanced net ionic equation. Did I not say that, Mr. Moore? Probably not. Or don't balance it. It's fine.
Doesn't matter.
Doesn't it? Yeah,
Okay.
whatever. Yeah.
We're at our lab station.
We are, and so now we're ready to titrate. Again, we have our permanganate solution in the burette. It's got a beautiful purple color.
Wow, what a nice color that
It's a
is.
great color. And remember, we know its concentration. It's 0.150. So we'll use our known permanganate solution to titrate our unknown hydrogen peroxide solution. So you are looking at sample C here.
Okay.
Okay, and what we'll do is we'll measure out 10 milliliters. Now I show you the cylinder that we're using.
Yeah, how's that graduated?
Yeah.
Oh,
Do I? I don't know if I need my hand back here or not.
So the cylinder is graduated to the 10th place.
Yep.
Okay.
Okay.
And you're measuring out 10 milliliter, 10.00 milliliters?
I am trying to do my best here. Okay. Now, as you know, many of these aqueous redox reactions have to be either acidic or basic solution. This one's going to work if it's an acidic solution. And so Mr. Moore made up some 6 molar sulfuric acid, and we're going to give a couple healthy squirts of the sulfuric acid.
Oh, whoops.
Why did I do that? That was really stupid. It's okay though, because I've already measured out the peroxide. I'll just dump it in the flask. That's the part I forgot about.
Yeah, if it would have, some of it splashed out of the graduated cylinder, that would have been a problem, but it didn't.
Yeah. And I don't have to measure the exact amount of sulfuric acid. We were just trying to make sure we have a big excess of hydrogen ions. And the sulfate ion from the sulfuric acid is just a spectator. I mean, it's not going to show up in your net ionic equation. Okay, so my peroxide solution's acidified. We're ready to titrate. And we ran a fast and sloppy trial already. So we sort of have a ballpark idea of how much this is going to take. And so here we go. Did you show them it's at 0.00?
It is 0.00, yeah. Looks like it's a little bit above the line.
Oh, should we?
I guess I thought when I filled it, it was right on the line. It's hard to measure the permanganate because it's so deep in color, you can't really see through it to see the meniscus. So I guess we're stuck kind of just looking at the edge of it. But let's run some out of it.
Okay.
Well, you don't have to take it out, just put a drop into there.
Okay. Oop. Guess what I did. How's it look?
It's pretty close. Just use the edge of it. I think it's right there at
I
0.00.
ran out more than a drop, so that's fine.
It's fine.
Is it okay?
Students, is that fine? Yeah.
I mean, honestly, it's not my grade, so if it's not exactly.
Yeah, I mean, we're not suffering at all.
Yeah. Okay, here we go. Now you can see
Where's all the purple?
the purple's disappearing, right? The permanganate's got that nice purple color, but Mn+2 ions are colorless.
That is
And-
so cool.
Yeah. So permanganate's nice because it's its own indicator. Remember in the last lab, we had to add some phenolphthalein so we knew when we hit the stoichiometric point.
Mhm.
We don't need to do that now. You know, as we're titrating here, the peroxide is in excess, and so the permanganate's used up very quickly. But what we're looking for is that drop that turns this pink and keeps it pink. And also, Mr. Moore, it looks like there's more than just a color change going on.
It does. What else can we see? Everybody see that? Those bubbles just from mixing two liquids together? It doesn't look like it.
I don't think so.
I think this reaction is generating some bubbles.
Yeah.
Which, think about what's happening. You see what the chemical equation is. Make sure when you do an experiment that your observations are consistent with what the chemical equation shows. I think this one is.
Yeah.
Now this group that has sample C is the lucky group. This is our highest concentration of
Mhm.
peroxide. It takes a lot of permanganate to get to the stoic point. Yeah, we're already down through about 20 milliliters
Right.
and still going. So what are we looking for our endpoint?
Oh, yeah. So we're hoping to catch the drop that turns it pink and keeps it pink.
Because at that point, the peroxide has been all used up, and there's nothing then that can react with the permanganate.
Right.
We're going drop by drop. You are.
I'm trying to go drop by drop. Yeah. Pink's hanging around longer.
Ooh.
More, you think?
I think it's pink. It's no longer clear.
We got one drop that's
So
hanging.
yep. Take that hanging drop, and that's going to be it. But there.
There we go.
Once you're past that endpoint, if there's no peroxide, it just stays fabulous pink.
We're close to the clamp. Is it focusing on the
Yeah.
clamp?
Well, it's focusing on something else. I'll just move a little closer to it.
Can raise it up.
Oh, there we go. Just caught something else. Okay, so there's our final volume. Initial volume was 0.
Yep. All right, so let's reload and give you one more trial.
We'll call that one trial 2 because trial 1 was done off the camera. Now, if we had gone over 25 milliliters, we would have to refill the burette, but
Yeah.
I think we're good.
Okay. Got our peroxide measured out. Acidify it. So
Yeah,
is
there's
it-
no reaction here with the peroxide and the acid. That's just,
Mhm.
you've got an acidified peroxide solution right now.
Right. Okay, are we ready? So we should be able to take it down pretty close to 46, right?
Mm-hmm.
It's always amusing in class when students forget to acidify
Yeah.
the peroxide, because then you never get the color change.
Mm-hmm. We just hit 32 ml. We're going down to about 46.
Yep.
Yeah, the burette has a tiny little opening in it. It takes a long time to drain it out. Almost to 40.
Yep. Okay. About 45, I guess. This burette is touchy today, boy. You gotta be careful to just get one drop. Ugh. Ooh, is that it, Mr. Moore? So,
I think that's it. And here we are down at the bottom part of the burette. All right.
yeah. Can't remember, I must have mentioned, this is sample C. Did I mention that?
I think we did.
Okay, yeah, this is sample C. And, yeah, good luck with that. You got two good trials, they average together there.
So we'll have the question in class. What are we trying to actually solve for? We'll
Right.
talk about in class.
Yes, have a good day.